Welcome to our channel. Astronomers just witnessed an interstellar object do the impossible. The stars wheeled in their ancient patterns above the observatory domes. It was November 2025. Astronomers were tracking a faint, new speck of light. They designated it 3I Atlas. The 3I stood for the third interstellar object ever identified. It was a visitor from the vast ocean between stars. Its trajectory was the first great clue. This was no ordinary comet from our solar system's icy fringe. 3I Atlas was moving far too fast. It was on a hyperbolic path, a single, unstoppable arc. It had been flung from another star. It was now diving through our celestial neighborhood. Scientists knew they had a unique opportunity. They pointed every available telescope toward the interloper. The initial data began to trickle in. It confirmed the object's incredible speed. This velocity was the definitive proof of its interstellar origin. Nothing from our own solar system could achieve such a path. The object was a fossil from a distant planetary system. It carried secrets from a sun humans would never see. Excitement spread through the global astronomical community. This was a pristine sample from another star. Every observation was precious. Every measurement was a chance to touch another world. Then came the first major surprise. Astronomers analyzed the comet's coma. This is the glowing cloud of gas and dust that surrounds a comet's nucleus. They expected to see the signature of water vapor. Water ice is the primary ingredient for most comets in our solar system. But the spectrograph told a different story. The data revealed a massive plume of carbon dioxide. The coma was mostly CO2. This was bizarre. It was the great CO2 mystery. Comets from our Oort cloud are dominated by water. This object seemed to be built from different materials. It was forged under different rules. Scientists were puzzled. What kind of place creates a comet of dry ice? The strangeness only deepened. Researchers turned their spectrographs to analyze the object's dust. They were looking for common elements like iron and silicon. What they found was even more confounding. The spectra showed a clear and unusual signature. There was more nickel than iron. This nickel-to-iron ratio was off the charts. It was a ratio not found in natural space rocks. It was, however, a ratio found in certain industrial alloys. The phrase industrial nickel ratios began to circulate in private briefings. It was a finding that defied easy explanation. How could a natural object have a composition resembling manufactured metal? The scientific reports became more cautious. The language grew more measured. But the mystery was undeniable. Another puzzle was the object's appearance. Comets are famously known for their two tails. A dust tail glows by reflecting sunlight. An ion tail is pushed straight out by the solar wind. 3I Atlas had a faint ion tail. But where was the dust tail? The initial lack of a dust tail was a major problem. It challenged all the initial size estimates. Without a dust cloud, astronomers could not accurately gauge the nucleus's size. Some models suggested it could be much larger and much darker than first thought. Perhaps its surface was unlike any comet seen before. Perhaps it had no loose dust to shed. The question hung in the air: where is the dust tail? As November progressed, 3I Atlas continued its plunge toward the sun. The solar heat intensified. And then, something changed. A new feature emerged. A faint, teardrop-shaped plume of dust began to form. This was not a classic, streaming dust tail. It was a compact, shifting cloud. The story of the object was evolving in real time. A changing tale, a changing story became the new headline. The object was reacting to the sun in a way no one had predicted. The new dust was a clue. It suggested the surface was beginning to erode. But it was eroding in a strange, localized way. The scientific plot had thickened once more. Into this scene of growing perplexity stepped a familiar figure. Harvard astronomer Avi Loeb entered the conversation. He had previously gained fame for his controversial views on the first interstellar object, Oumuamua. Now he turned his attention to 3-Ia Atlas. He published a provocative paper. It was titled Harvard's Controversial Claim. Loeb argued that the collection of anomalies could point to an artificial origin. The hyperbolic path. The strange CO2 composition. The industrial nickel ratio. The unusual dust activity. He suggested that, while extraordinary claims require extraordinary evidence, we must allow for extraordinary possibilities. Perhaps, he mused, this was not a comet at all. Perhaps it was a piece of alien technology. A discarded light sail. A derelict probe. The scientific community reacted with a predictable mix of intrigue and skepticism. Why scientists are skeptical became a crucial part of the narrative. The mainstream perspective was clear. Unusual phenomena do not automatically mean alien technology. The history of astronomy is filled with mysteries that later found natural explanations. A spokesperson for the Jet Propulsion Laboratory gave a typical response. She said, "Our position is to exhaust every possible natural explanation first. The universe is capable of producing things we haven't seen yet. That doesn't make them artificial." Many scientists pointed to the new dust plume as evidence the object was, after all, a type of comet. Just a very, very weird one. The debate raged in journals and on social media. It captured the public's imagination like few science stories ever had. The only way to settle the debate was with more data. The search for definitive proof was on. The world's most powerful telescopes were locked onto the object. But the most exciting opportunities were yet to come. The object's path was taking it on a remarkable journey through the inner solar system. It was giving our robotic explorers a chance for a close-up view. The view from Mars was going to be spectacular. The Mars Reconnaissance Orbiter, or MRO, was in a perfect position. In early December, 3-Ia Atlas would make a relatively close pass by the red planet. The MRO's high-resolution camera was scheduled to take hundreds of images. Scientists hoped these images would reveal the object's shape and surface features in stunning detail. Would it look like a lumpy, natural rock? Or would its geometry be unsettlingly sharp? There was another, more daring plan on the books. An older probe, the Juno spacecraft, was currently in orbit around Jupiter. Mission planners performed a series of complex calculations. They found a potential trajectory. Juno's potential interception was a long shot. But if a small course correction could be made, Juno might get one final look at 3-Ia Atlas in March of 2026. It would be a distant observation. But the data could be invaluable. It would show how the object had changed after its encounter with the Sun. These were the missions that could provide the answers everyone was seeking. For amateur astronomers and the public, the question was simple: when can you see it? The answer was both exciting and disappointing. 3-Ia Atlas was not visible to the naked eye. It was too faint. But by late December 2025, it was moving away from the Sun's glare. It would become a target for medium-sized backyard telescopes. Astronomy clubs around the world organized viewing parties. People pointed their telescopes at a dot of light that had come from another star. They were looking at a genuine interstellar wanderer. It was a humbling and thrilling experience. Avi Loeb, in a media interview, framed the moment perfectly. He called it a blind date with deep space. We did not know what was coming. We had no idea what we would find. The encounter was brief and mysterious. We had to learn everything we could in a very short time. This single quote captured the exciting, yet uncertain, nature of the whole event. Thank you for watching. If you enjoyed this, please like and subscribe for more stories each week.